Good morning, everyone. Apologize for the slightly late start while we were sorting a few things out. My name is Amanda Sheffield, and I am the Regional Drought Information Coordinator for NIDIS for California, Nevada, and I'm affiliated with the Cooperative Institute for Research and Environmental Sciences at CU Boulder. Welcome to the December California, Nevada Drought Early Warning System Drought and Climate Outlook webinar. Normally we host these actually in November because we're usually every other month, but because last Monday was Thanksgiving week, we decided to bump today to today as well. So you may know that these webinars are usually in November, but just early December this time instead. So thank you for those that have joined us previously and those who may be joining us for the first time. This webinar is co-hosted with the California Nevada Adaptation Program and NOAA CAP team. As I mentioned, we designed these bi-monthly webinar series to provide the region with timely information on the current drought status and associated impacts, as well as a preview of developing climatic events. Before we get started, please note that this webinar is being recorded, and the recording and a brief summary will be available on drought.gov and our YouTube channel later this week. And there should be a link already in the chat, and I'll put one in again at the end later for where you can find our YouTube if you want it sooner than we'll say when we email it out. We've got a great set of speakers this week covering current conditions as well as outlooks and relevant tools and resources to monitor winter conditions in the region. Real quickly, I'm going to cover a few quick slides. For those that aren't as familiar with us, NIDIS's mission is to improve the nation's capacity to proactively manage drought-related risk by providing those affected with the best available information and resources to assess the potential for drought and to better prepare for, mitigate, and respond to the effects of drought. We do this through advancing regional drought early warning systems, of which California, Nevada is one of them, where we work with new and existing networks of federal, tribal, state, local, and academic partners to make climate and drought science accessible and useful for decision making. We do this through a few different activities, including observation and monitoring activities, research and applications, planning and preparedness efforts, prediction and forecasting information, and communication and outreach, such as webinars like this. And then this is just a quick reminder, if you want to learn more about us, go to drought.gov, and I'll talk a little bit about some of our latest and greatest tools and things at the end. But just as you need to know where to find latest news from us, past webinar recaps, including where this webinar will be hosted, you click on news and events, and you'll get these tabs where latest news, past webinars, and you can also, it's the same place where you'd sign up for NIDIS emails. So many of you are on our California, Nevada list, but if you want to sign up for our national newsletters, any of the other signups, including for like drought conditions in your area or things like that, you can sign up for that on drought.gov. With that, we'll go ahead and get started. One of our speakers is doing quite a bit for us today. He's Pete Fickenshire, I'll let him pronounce that, from NOAA's National Weather Service California Nevada River Forecast Center. He's going to be providing the drought and climate update and outlook, as well as the some tools and resources from the River Forecast Center. And with that, Pete, I will pass control over to you. And a reminder, as we're getting started, usually we do a question and answer at the end. You can enter questions in the question box at any time. But I do think we decided with Pete that after he does his drought and climate outlook, we'll take a short break, do a few questions if there are any, and then we'll hop into tools for the rest of the webinar. So feel free to pop questions in the questions as they come to you. And Pete, it looks great, so I'm going to turn it over to you.
Okay, thank you, Amanda, and thank you for joining our Drought and Climate Outlook and update. My name is Pete Fickenshire. I am the Development and Operations Hydrologist, that's a mouthful, at the California Nevada River Forecast Center. Been there for well over 25 years now, and our primary mission has been kind of twofold. One is the area of flood forecasting, the short-term events like this one you see on the screen from a couple weeks ago. But we also do a lot of water supply forecasting, keeping track of snowpack, soil conditions, and what kind of inflows into reservoirs that people might expect over the coming water year. This image was from November 20th. It's kind of the very start of kind of a three-day atmospheric river event that really kind of turned the corner for us in terms of water supply and drought conditions, at least initially for this water year. And you can see the improvement that we've seen over the last couple weeks. The leftmost graphic shows the drought monitor for November 19th, and then on the right, after that week of 2 atmospheric rivers, a lot of improvement occurred, particularly in Northern California. But we still see a lot of dry conditions and lack of improvement throughout Nevada, Southern California, and the deserts in that region. One of the primary indices, kind of quick picture for us as water supply forecasters, particularly for the state of California, one of the key indices is this 8-station index, which is a collection of 8 precip gauges over the northern Sierra Mountains, all the way from Mount Shasta down through the American River Basin. And what's great about this index is that it has a long period of record, which gives us a good idea of how we're doing this year compared to climatology, a 104-year record. And the 5 months leading up to November this year were really dry. It was the 12th driest in that 104-year record, with only 1 3/4 inches of rain over those 8 rain gauges. But since November kicked in, particularly the last 2 weeks of November, we picked up 13.5 inches of rain, which was the 10th wettest November on record. And you can see on that blue line down at the bottom there, our current precipitation jumped from basically a 50% year all the way up to 170%, 168% for December 1st. And that just shows one of the things we see all the time out here in California and Nevada is just the highly variable nature of precipitation. This is from a paper done by Mike Dettinger back in 2011, just showing the coefficient of variation. How much does rainfall change from year to year in our region? And you can see California really stands out compared to the rest of the country. And the rightmost graphic there shows the average number of days per year to get to the halfway point in a water year. And again, California and Nevada show anywhere from 5 to 15 days is all it takes to get half of a water year. Well, this one event for Northern California, it only took 3 days to get quite a bit of our water year totals. Kind of 3 regions in particular I've highlighted there with the red circles. The lowermost is the one in the kind of Russian River Napa region, where you see a couple of gauges there. One picked up, one of our really wet gauges called Venado picked up over 20 inches of rain in just 3 days, which was, it's a wet station. But even then, that was a third of a water year. Santa Rosa also picked up quite a bit. Then also in the Shasta drainage up near Redding, Shasta Lake picked up quite a bit. And then the Feather River Basin also did quite well. And you see the dashed red line there just shows the sharp cutoff too, that this 3-day rain event didn't help as much south of that red line. We called it the I-80 demarcation, it happened to be. And just again to show how rare this event was, looking at what we call the NOAA Atlas 14, you can run some statistics on, how does this rainfall event compare to what might occur in a 100-year or 500-year type of event. And that 10.2 inches that you see on the map over Santa Rosa for 2 days amounted to a 1,000-year return interval. Again, just an incredibly rare event. And we were actually pretty fortunate in terms of flooding, simply because we had dry soils coming into this event. And that was really enabled a lot of the watersheds to absorb at least the initial part of that rainfall. We still did see some flooding, but it wasn't as severe as it could have been. And then we did have a second atmospheric river that hit the central part of California from November 25th to the 26th. Again, picking up anywhere from 2 to even as high as 6 or 7 inches in parts of the upper Sierra. And then on the right, you can see a gridded look at all these, how much water we've gotten for the whole year so far in California and Nevada. And again, Northern California is flush. the central part of California picked up a good start anyway, but there were some rain shadows in the northern or in the central coast area, as well as in that region kind of south of Sacramento. Kind of an area in between the two atmospheric rivers hasn't picked up much rain there yet. And of course, Nevada and Southern California have yet to really pick up much rainfall. And so that leads us to the, again, how much we've improved. The green area here shows the 1 week improvement for November 26th drought monitor map. But again, Nevada and Southern California has even seen a little bit of drought degradation in terms of the drought monitor. But it is early in the water year. There's always hope for some change. And what might bring change is, of course, broader climate patterns. And so I'm going to show about 6 or 7 slides here that come off of the Climate Prediction Center. They do a weekly update of how is El Nino, Southern Oscillation, the ENSO development happening. And we're currently continue to be in a La Nina watch. It's been a long watch and a long wait. People are still hopeful that we might see something later this winter. And you can see here how there's one region in the equatorial Pacific that people really monitor to see whether an El Nino or La Nina is going to develop. It's that Niño 3.4 region you see on the map on the lower left. And that currently is standing at about just below normal, 0.3 degrees Celsius below normal. But much of the last few months, there's some initial movement away from the El Nino you see from January, February of last year down into more below normal sea surface temperatures of the last few months. And but it's kind of been hovering in what we might call the La Nada area. It's a neutral, neither El Nino or La Nina. One of the reasons people are hoping for more La Nina conditions are looking below the surface of the ocean down to 300 meters. There is quite a large pool of cooler waters, below average temperature waters, which really developed back in February and March of this past year. And then looking ahead, people start, analyzing what the different climate models are showing in terms of the development of El Nino conditions at the sea surface temperature in that Niño 3.4 region. The IRI is the International Research Institute. They do a survey of several different, both dynamic weather models, climate models, as well as different statistical models. And both of them are showing that dark green or thick green line and the thick red line are kind of showing there's still borderline, could be La Nada, could be La Nina. The leftmost graph is from October. The one on the right is from November. Not much change in terms of the weather models. And yet, looking at how things have been developing in terms of the probabilistic outlook that CPC is putting out, the Climate Prediction Center, again, back in October, they're predicting a 71% chance that we'd be in La Nina by now. And then in mid-November, it was dropping to 57% chance. And, looking at what we're currently at, it's more and more likely that we won't be reaching La Nina conditions until perhaps mid-December or later. The IRI, again, more of a using not just North America, but also looking at international other weather models, their predictions have been more or less robust in terms of seeing a La Nina occur. Again, the October prediction was showing 52% chance of La Nina. Now at this point, mid-November, they're already looking at La Nada or neutral conditions are much more likely. This graphic comes from the CPC. It's again showing the development of the sea surface temperatures What I like about this, it shows the light gray lines are every strong El Nino since 1950. Since we had such a strong El Nino this past the previous winter in water year 2024, what happened with other strong El Ninos. And you can see most of them ended up in La Nina situations, but this one, the purple line in the middle, has yet to drop below that La Nina threshold. And there were 2 water years that kind of hung into that neutral territory. And interestingly enough, the overall weather for those years ended up being quite wet, wetter than average. And so far I've been kind of talking primarily about the sea surface temperatures. There's other way to look at the El Nino signal, and that is, one is the Southern Oscillation Index. This mostly comes out of the Australian Bureau of Meteorology, where they are a little closer to the equator there and have developed a long history with the Southern Oscillation Index. And again, the past 2 winters, you can see the La Nina from water year 2023, kind of like with most of the things south of the equator, they've reversed things. So the La Nina is actually on the top in this case. They have a positive SOI, indicates a La Nina situation, while a negative SOI is an El Nino condition. And so last year, while the sea surface temperatures were certainly in that warmer than average status, the Southern Oscillation never really caught on until late in the water year. And then on the right, you see the preliminary SOI values have been in the La Nina territory probably for nearly a month now. Another way to look at ENSO is also through what is called the multivariate ENSO index, which tries to combine the sea surface temperatures, the atmospheric pressure like the SOI, along with outgoing long wave radiation and wind patterns. All those things get combined into multivariate ENSO index called the MEI. And that also, you can see on the rightmost graph, has been just below the 0 line, and so kind of on that borderline again, borderline La Nina versus La Nada. And so what does a model say? This is a North American multi-model ensemble on the left. If you combine all the different models, individual models on the right, only one of those is really showing a neutral or an average year. Most of them are showing below normal rainfall for December, January, and February. And so the total ensemble then ends up being about a 40 to 50% chance of being below normal for California and Nevada. And the same is true with the international multi-model ensemble. That this pulls in some other models from France and from the European Union and British. And so there also you see the typical La Nina pattern where it's wet in the northwest but dry over much of California. So CPC came out a couple weeks ago with their precipitation outlook and kind of goes with the primarily that La Nina signal where the northwest has a better chance of being above normal. The southern part of California and southern Nevada have a slight chance or shade towards below normal, a slightly higher probability. But most of California and Nevada is still kind of up in the air. It's equal chances. So it could go either way, which doesn't give us a whole lot of information, I suppose. Temperature is also the same, below normal in the northwest, while above normal chances in the southwest. And what does that mean for the drought outlook? Again, this was the drought tendency during the coming December through February timeframe. And again, the northern part of our region has already seen some improvement, that of Northern California. So this was put out November 21st prior to that big rain event. But still seeing a likelihood that drought would persist in that Southern Nevada, Southern California region. And then finally, before we move on to the tools, one of the things I often look at when I'm kind of considering, what are the chances, or what's the trend like during a current water year. There's actually some pretty good analysis that you can do just from looking at what happened during the fall. This is again pulling in that 8-station index, that 100-year record, and saying, well, what were the 34, 35 the wettest October, November falls that happened during those 100 years, and then looking at La Niña, neutral, and El Niño conditions. And so we're going to focus on La Niña and neutral. And you can see very few of those years ended up being on the dry side for the 8-station index. That if you started out wet, you're likely to at least be near average or above average going throughout the entire water year, spanning all the way out through September of 2025. So that gives us a little bit more hope that all the models are showing, maybe a dry winter. Hopefully, when the end of the water year comes around, we'll at least be in the average to above average category. And since a picture is often worth 1,000 words, snow drought is always a concern, and that was certainly a big concern. At mid-November, this is from November 19th, webcam up above the Yosemite, and all it took was 1 week of weather to produce, I think it's up to 5 or 6 inches of water equivalent in the snowpack. So the snowpack is off to a good start already here at the beginning of December. And with that, I don't know if there's any questions in the chat. One last picture. This was a hike I took with my son and some of his friends up above Lake Berryessa. Again, while the hills look really dry, it's mostly the grasses that have died off. If you got close to those gray brown hills, you'd actually see a lot of new growth starting to push through the last year's dry grasses. So I think there's good hope for green hills in the future. Amanda, do we have any questions, or should I move on?
As of right now, there's 2. The first one, I think this one came in sort of early. They thanked you for the presentation, but said, can you share with us how you measure snowpack? Or maybe a little more detail on that.
How you measure snowpack?
Yes.
I'm sorry. Okay. I'll show you some of the things. I'll kind of get to that during our tools. How's that? Because I'm going to talk about that.
Good. And the other question is why no analysis of PDO, which is the Pacific Decadal Oscillation, for those that don't know. They reference that all our analysis shows that PDO and AMO are the driving cycles for climate variability.
Those are both, decadal oscillations that people watch. There are certainly things that do play into it. It's hard to, when you get down to year variability, though, it's really hard for, at least on the West Coast, to, you can see, wet years and dry years, both within those cycles. And so, but yeah, I was looking at the AMO and PDO just this morning, and certainly PDO has gotten quite a bit further negative, which would, again, encourage, kind of lean towards more La Niñas showing up. So it's almost surprising that the La Niña hasn't really developed really well this year. But I think either case, whether we stay neutral or La Niña, again, this wet start to the winter, I think, gives us a good hope for some continued wet weather eventually after this dry spell we're currently in. Does that help?
Yeah. And those are the only questions I have so far. So if you want to hop into tools, take maybe up to 10 minutes, and then Julie will go for the CWT. Okay. I'll wrap it up after that.
All right. So our website is fairly simple, cnrc.noaa.gov. And it has an interesting history in the sense that we almost started it because we wanted to monitor ourselves since, weather doesn't stop, but we have a pretty small staff, and we're constantly trying to find out, particularly during flood events, how much is it raining what are the rivers doing, how do our models look in terms of forecasting rivers and water supply. So if you go to our website, you'll see two things. Primarily, the first thing you'll see probably is our map, and the colored coded dots are the different rivers. Some of them are going to go over a monitor or flood stage, they'll turn color. But these are all 5-day outlooks, and you can kind of hover over these if you wanted to see what rivers are doing. We also have a number of tabs at the top, and probably for the area of drought monitoring, the climate one would be the one that you can toggle through some interesting products to be able to see not only the drought monitor, but also different climate forecasts coming from the CPC, watching the El Niño, MJO, and other teleconnections. There are all different links that you can quickly get to from our site here. One of the products, though, that is probably more unique to our office, besides the river forecast, is that of precipitation. So on the right of the map, there are all these different drop-down tabs that you can access to find out different information. And one is every day we go through a process of quality controlling a couple thousand or several hundred anyway. I guess it's 860 different rain gauges throughout our region. Since rain gauges can produce erroneous data, we have to go through and QC them. You can see how much rain has happened over the past 24 hours. But we also have a picture of the water year and what's the percent of average of rainfall for the water year. And again, you can see the well above normal in Northern California, the well below normal in Southern California, and kind of a mix of some wet, some dry here in Central California, as well as into Nevada. And these can also be gridded into a form that helps you see on it extends the point data into a grid. And for some reason, it's taking a long time to load. So we'll move on. I showed one of those gridded products earlier in the presentation. We also do a 6-day gridded QPF, where we're forecasting how much rain is expected to fall, precipitation over the next 6 days. As you can see, it's pretty dry right now. But we also were asking about snow. We monitor, one of the ways we measure snow is through what are called snow pillows, which are basically, about 10 foot by 10 foot pad, and the snow presses down upon that pad and produces a certain weight. And based on that weight, you can determine how much water is in the snowpack. So whether it's a thick snowpack or a thin, what really matters is how much water is in there. And you can see for our region right now, most of the snow pillows it's a mix, but definitely in Northern California has the highest percentages. And then some of the lower elevation ones also have not picked up as much snow as some of the higher elevation ones. But you can zoom into each of these snow pillows to find out how the snowpack is doing. And those are nice because they update every day. Also in our office, we're pulling in, whatever other information we can gain. One of the projects done through the California Department of Water Resources is an airborne snow survey, where they fly planes over the snowpack and measure the depth of the snowpack using LiDAR. We bring that information into our office to see how well our model is doing in terms of modeling that snowpack. So besides looking at observations, you could also look at what we call our simulated basin snowpack. And this looks again at how well is our snowpack doing in terms of our model. So our model, again, in the north is picking up quite a bit of snowpack already, and a few spots down here in the central southern Sierra. That's one way you can also look at snow. And of course, We also, if you want a wider picture beyond just our area, we highly recommend the NRCS, who also has a website which looks at a lot of snow pillows. And you can, if you're interested in particularly Colorado river water, you can get a sense of how the snowpack is doing in Utah and Colorado. And so it shows a much wider perspective. What else is it going to show? Oh, water supply. So if you go to our water resources tab, this is again a quick look at how does the water supply look for the April through July time period. It's called the seasonal volume. Or if you want to look at what the total water year volume looks like, you'll get a lot more river gauges involved in that. And you can see again in the north where we really picked up a lot of early rain, there's a better chance of being above normal. But you can click on any one of these. I'll go to the one that's a little more local, the American River here at Folsom Reservoir. And you can link there. If you click on the bottom link, you'll get to these, what do we call our water year trend plot. And these are real handy. You can see that the different colors here represent different likelihoods of reaching that level by the end of the water year. The blue line is, again, the average that you'd expect on an average year. The green line is actually the median, which is often below the mean because the really wet years tend to skew the mean to a higher level. And this blue line kind of shows what our model has produced every single day over the last couple months. And you see just about a week prior to that big rain event, things started to improve. And then once we looked beyond that big rain event from November, late November, and started to see the dry start to December, since our forecasts are including 2 weeks of a weather model, things can drop off even before, during a bigger rain event. And so things really dropped off following that rain event as we've kind of gone into this dry period of early December. And if you want to look at different locations, you can scroll down. One of the ways you can kind of get a quick look at the whole Central Valley is going to this, what we call the Central Valley Water Resources Index. This pulls in 8 different rivers, averages and pulls them all together. And this will give you an idea of what the whole state of California might be looking at. Again, we're somewhere between median and the mean, so, which is a decent average start right at this point. So that's water supply. I also wanted to show, you can go from there if you want to just zoom in to, say, the Sacramento Valley or the San Joaquin Valley, you could do that. Again, the San Joaquin is not doing as well, didn't participate in that first atmospheric river, so they're still hovering down here below the median. So those are our primary water supply. I mentioned the climate. Again, if we want to go back to this, a quick look at the drought monitor, there's a lot of maps here that you can scroll through, as well as temperature plots and precipitation plots. I just encourage people who are interested to explore, and I want to hand it over to Julie, because I know their site has a lot of great tools for monitoring as well. I think I'll stop now.
Great. Thanks, Pete. I'm going to pass, Julie, I'm going to pass over to you, but ask you one more question, Pete, because someone had a follow-up from the snow question. Julie, I'm passing it to you, but Pete, they had a quick question. Thanks for touching base on how you all measure snowpack. They're curious about the room for error and more, how SWE translates to reservoir forecast, and eventually what is available for public use.
Yeah, so there's many different sources of error that goes into these water supply forecasts. The biggest one at this time of year, of course, is the weather uncertainty. And you can see the wide bands that we had in those water supply forecasts. But as you move closer and closer to the springtime, snowpack uncertainty becomes more important. And so we're constantly monitoring the snowpack. There's also uncertainty in soil. There's uncertainty in our hydrologic model as well. All those uncertainties do play out, and we try to include as many of them as we can. But one of the weaknesses of this method, and that's why we work together closely with the California State and other NRCS forecasters. They often are able to include some of that other hydrologic uncertainty into their forecasting. So I encourage you to look at their forecast as well.
Great, thank you. With that, go ahead, Julie.
Great, thank you. So I'm going to go through the CW3E, their Center for Western Weather and Water Extremes website. So we work largely on the weather timescale, and I will also show some of the sub-seasonal work or forecasts that we have as well. And so I've pulled up the different forecasts, but if you go to the website, which is cw3e.ucsd.edu, under forecast, all the stuff is under here. There's a lot of information, so sometimes it takes a little time to load, and I did not want to use that time here. So the first is I'll be showing two different types of forecast information. One is called the deterministic, which is one model run. And then I'll go into what we call the probabilistics, which uses many model runs in an ensemble to get at the uncertainty in precipitation. And we largely focus on atmospheric rivers. And so first, like I mentioned, I'll start with the atmospheric river. We generally measure atmospheric rivers in IVT, or integrated water vapor transport, and it's the combination of the water in the atmosphere, which this is IWV, integrated water vapor, and the winds. And so I often like to start at this California, Nevada region, the US West Coast, to see what I can see. And then right now we don't have anything really coming towards the US West Coast, but you can move forward in time, and we'll see that it looks to there's an atmospheric river heading towards the Pacific Northwest. And here's the date that the model was initialized, so that the model was run. And then this is when it's valid. So this would be the 6th of December, so Friday, where this atmospheric river is making landfall along the US West Coast. And we showed two different models here. One is the GFS, that's a US global model, and one is ECMWF, that's a European model. And so the times don't match up perfectly just because of when we get the data from the various models, but you can kind of toggle between the two different models, and you can see the timing and location of this atmospheric river in the forecast are a bit different. So this begins to show you a little bit more of that uncertainty. Sometimes, like I said, the US West Coast isn't far enough out, and so like to look at this North Pacific region, and same, if you go to the same time frame, you can see a little bit, oh, this is the same one. There we go. You can see more into the Pacific. This is the current atmospheric river making landfall in Canada and British Columbia area. But then, here's this shorter, smaller atmospheric river that we were just looking at from the US National Model GFS, and here's looking at the ECMWF. So you can see the two different models from the two different agencies are showing different forecasts, but still that there may be something hitting potentially the Pacific Northwest or potentially up into Canada later. And so these, like I mentioned, are the deterministic models. And then if you go back to the original, if you go to forecast, and this will load, so this is where you can see those models. And this goes through all those deterministics. So it's one model runs that shows the difference between the US, the GFS, and the European model. We also run an in-house model called Westworth, which is focused on the Western US and extreme precipitation. And so a lot of the similar products can be seen from our Westworth model. And it's run at 9 kilometers and 3 kilometer domain. It's run twice a day for those 2 different locations. And then after going through the deterministic models, what we'll come to, I think, is one of the most popular, most often used, is the AR landfall tool. And this is the beginning of the probabilistic, or using multiple ensemble numbers to show what might be coming in the forecast. And so again, we have 2 different models. You can pick here between the US national model or the European ECNWF. And we normally say atmospheric rivers are have a threshold of 250 kilograms per meter per second, but you can look at different thresholds, higher, or these actually have vectors in them. And then you can actually look at different locations. For example, if I switch to the foothills, you can see how this dotted line moves inland. So I'll say for the coastal right now, and what this is showing is the probability of atmospheric river conditions along the west coast. And so the purple, the warmer colors, are higher probabilities. It's not intensity, but the higher probabilities of an atmospheric river making landfall along the coast. And generally, actually this far out, seeing, these are relatively high probabilities from 10 days out. So there's an indication that something in this extended range might be coming. We can also look between models to see if both models are showing something in that extended range as well. And you can see that there is something here in the European model as well, but the probabilities are different. And then similarly, the probability, like we saw in the deterministic for the European, are a bit higher compared to the US national model. So you can go back and forth, and you can actually do a comparison between the two, with the green showing where the European model is more certain and the brown showing where the US model is showing more certainty. And then there's additionally, I'm going to focus on the Pacific Northwest just because there's more action there right now. But what this is showing is this is the IVT magnitude at a specific point. So here's in very northern Washington, and what you're seeing is all the various different model runs of at this location what the IVT is. And if it's above 250, it's atmospheric, it's a weak atmospheric river conditions. And so you can see there's a fair bit of uncertainty. The blue line is the 1 standard deviation, or the blue and red line are the 1 standard deviation plus or minus. The green is the mean of all these different ensemble numbers, and the black is that control run, or that deterministic run that we were talking about before. And so again, you can choose your location, you can choose your transect, whether it's inland or and you can also look at the model you want to look at. And you can even combine the 2 models where you see a lot more of the spread between the 2 models. So another thing that we look at for situational awareness is called the atmospheric river scale. And different to say the hurricane scale, the atmospheric river scale is point dependent, and so it's specific to a location. So the same atmospheric river can have a different number depending where you are. So for example, over this past week, in the past 7 days, there was the same AR had it was an AR1 and an AR3, just depending on the location. And you can see similarly, the one for the Pacific Northwest, this is from the US national model, depending on the location where you are, ranges from an AR, not an AR, right, to an AR1 all the way up to an AR3, depending on location. And similarly to before, you can actually look at the plume diagrams, and it marks, what has happened in the last 7 days based on the observed or the model runs. And then this is looking at the forecast, and it highlights what the AR scale is for that location. And so this right here is an AR2 because it's between 24 and 48 hours, and it's between a weak and moderate AR, so 500 IVT to 750. You can even take it a step further if you're interested. For the same location, you can look at all the different model runs and which ones are showing an AR2 versus an AR1, and you can see the probability of the different AR scales for that location, and you can pick your location of interest. The other thing that we have on our website is this precipitation page, and so it looks at the total precipitation for a whole bunch of different models. And so I just picked a watershed where there's actually, it's the Chehalis watershed in Western Washington. And because it had precipitation forecasted in the next 10 days, and so you can see, between the different models. So here's the deterministic, the operational models for the GFS, the European, NOAA Weather Prediction Center. There's a national blend of models, and then the ensemble mean. And so you can see the total QPF for that watershed, the mean aerial precipitation, what volume that would be in acre feet, and then the duration, because different forecasts go out for different amount of times. And then this actually breaks it down day by day. So the first 3 days, all the models are showing no precipitation, and then day 4 is when you start to see the precipitation pick up. And some are, the GFS right here is showing a lot more precipitation than some of the other models, really in that day 5 and day 6. And then if you go down, you can actually see how this compares in a graphical sense. Each of these different lines are showing a different model and the accumulated precipitation over the 7 to 10 day period. And then this is looking at the GFS and the ECMWF ensemble. And so you can see the range of precipitation for that watershed. And the last bit here is looking at the model in terms of each of the ensemble members of showing how much precipitation will come in the 6 hour increments. And so it breaks it down in terms of timing as well, and showing that there's model agreements and disagreements. Real quickly, I'm going to switch to, we've actually reframed it, so the sub-seasonal and sub-seasonal. I'm going to focus, sorry, I was at the end of the website. I hope you're not getting dizzy. I'm going to focus mostly on the sub-seasonal weeks really 1 through 4. So this is looking at, for here you can pick your model. So NCEP is a NOAA model, ECC is a Canadian model, and then here's NASA's model. And so this is looking at week 4, and this is looking at AR activity, or how many AR days is the model showing. And so you can see relatively active into British Columbia area. This is what climatology would be for this time period. And then if you scroll down, you can see how anomalous this is. And so this is anomalous in terms of days, and this is anomalous in terms of percentage. And so at week 4, this model is showing that there's a higher likelihood of precipitation into the kind of British Columbia area. Like I said, you can look at different lead times. You can also look at different models to see how well they agree. And this is a bit anomalous that in week 4, they're both showing this more anomalous AR activity into the Pacific Northwest, but also this one, the ECC isn't quite as strong and is showing, farther south. So there are differences between them, but it gives you a sense of what the models are showing in week 4. This is a similar concept and idea, but instead of showing the atmospheric river days, it's showing how much total IVT, so that integrated water vapor, over that week period is the models are showing relative to climatology. And so this is for the ECC, the Canadian model, and you're seeing, similar to what we showed before, that, pointing more towards the Pacific Northwest and how anomalous this is in terms of percentage. And then you can also look at this at different locations. I'll stick to week 4. I'll move up. So it's maybe a little bit more interesting, but so this, you can see what ensemble members are showing weak to more moderate atmospheric rivers during that week. And so again, it gives you a sense of what the models are showing in week 4 for that extended range period. This is actually looking at the flip side of it. It's called a ridging forecast. And so the idea of when you have a ridge, you can see these red circles, it would cause atmospheric rivers or storm track to be pushed farther to the north, causing this region to be dry and different. And when you see the red ridging here, the Pacific Northwest is wetter, while the southern portion is drier. And then this in general is a bit weaker of a signal in terms of the ridge type. So for week 1 and 2, it's showing this north ridge type, and there's quite a bit of model agreement between this. You can also look at weeks 3 and 4, which we were looking at before, and it's showing, somewhere in between. Both of these are showing a fair bit of model agreement between these 2 ridge types. So I think from this we take that it looks like the southern portion of our region is, the models are suggesting based on the ridging would be dry, and there's more uncertainty in the Pacific Northwest. I'm going to skip the IRI, and then I'm going to move down to, this is what we call the MJO QBO outlook. This is solely statistical, and so there's 2 various different types of teleconnections. One's medium Julian oscillation, and the QBO, and these can work together or counter in terms of the likelihood of whether or not there's a chance for more increased precipitation or AR activity. And we've looked at this by region. And so right now, looked at Central California and the Mariel's precipitation, but you can change to AR currents or that total IVT, how much IVT is available. And so, like I said, this is entirely a statistical relationship, but when the MJO is in the current phase and the QBO is in a phase, this week is projected is statistically more likely to be dry. Similarly in week 4, and there's not necessarily this strong probability, right? It's all in the 37s at highest for it to be wetter based on the phases of the QBO, the Western QBO, and the MJO being in phase 4. The last thing I'll talk about is the odds of normal. And so this is a website of saying if we've received this much precipitation as of now, just historically, what are the odds of reaching normal? And so it hasn't updated for December yet. It updates, I think, the 5th of every month to make sure we have the data. You can see that right now the odds for parts of Nevada and Southern California are getting a bit lower given that we've had a dry start, but as we all know, anything can happen. Amanda, I'm sorry, I realized I went a little long, but I will stop there and turn it back to you.
Oh, this is all great. For those that are, a little bit of echo there. For the presentations and everything, if you have any questions, obviously we've shared a lot of tools and resources. Feel free to reach out to me or either the speakers. We'll make sure to connect you where needed. I'm going to wrap up here quickly talking a little bit, just a reminder about drought.gov and what information we have there before closing. So yeah, as I said, I just want to do a little reminder here, a little refresh of some of the new things we have on drought.gov. Since Congress has created NIDIS, we've always had drought.gov as the U.S. Drought Portal. It's the official U.S. Drought Portal webpage, where we provide up-to-date drought conditions from the city and county level to some information across the globe. We have very interactive and customizable maps now and data that show droughts in new ways. A newly updated historical drought tool I shared last year. Timely updates on drought information, including regional drought status updates, and you can sign up, as I mentioned, for local drought alerts. And there also is information under Research and Learn where you can learn to go back to the basics on drought or view often in our news or other articles, as you can see here, that we share are some of the latest, newest, innovative research on drought. oops. Yep. And also, Pete mentioned as we follow, we do try, and he was answering some great questions about snow. We do track it throughout the year. One thing that we produce on drought.gov is snow drought information. So you obviously can get some of the information from, for example, CNRC and others as well. You can learn a little bit more about snow drought on our Research and Learn webpage, as well as under our data and maps, which is where you find a lot of the data for monitoring and outlooks. And next week actually kicks off our first of what is our monthly December through June snow drought status updates. So for example, here's the link. This is a screenshot from last year's where the final update is always a summary of the year, but we will be kicking off this water year next week. So this is just a reminder that we do have snow drought information on drought.gov, and you can also get those updates will be out starting next week. As part of that, we've taken quite a bit of effort in order to get awesome automation to some of these information and tools, and one of those is the snow water equivalent conditions from the USDA NRCS. And so this is just, for example, a new map that we have on there where it's automatically bringing in this data for the watersheds and mapping it there. And this is a key map as part of our snow drought update, so we're excited that this is all automated this year. And just for example, this map and a lot of the maps on our website are customizable. So it has, you can often learn more about the data as well as see when the data is valid of. But here in the upper left, if you click links like this on any of our graphics, that means you open up a box where it lets you select the different layers, the county lines, the state lines, the backgrounds, the tribal nation lines. You can show the whole, depending on the map, the whole US, including Alaska and Hawaii, or you can zoom into certain areas. And then use Save Map, for example, to customize this to then a PNG or other file type map for your use. And so I was just using the snow map that's new, for example, but you can do this with many of the different maps on drought.gov. And then the last thing before I quickly wrap up, I'll mention, I was trying to think of what was new since I did a few minutes on drought.gov last year. And this is the one of the things we worked with the National Weather Service on adding were these drought information statements. So when a region goes into a certain amount of drought, it triggers these drought information statements. And now we have a home for them on drought.gov. You can see the webpage in the lower corner there. But everywhere there was an I, at least as of, this was November 21st, there was one of these drought information statements. So drought was strong enough and there enough that the local weather service office decided we need to do a drought information statement. So for each of these, and I'm going to pick one for example here in Southern Nevada, you can link to this statement from drought.gov, and then there's a whole PDF of information that you can review on what was that drought information statement and the conditions and why it was being released. So this one was because there was a hot and dry summer in that area, and extreme drought expanded up the Colorado River Valley, etc. So, and this was from November 15th, so there may be more updated information now. But that's something newer we do have on drought.gov. With that, I'll go ahead and wrap up since I'm already 1 minute over time. First, I want to say thank you all again for joining us today, and to our two great speakers, Julie and Pete. We hope you found this webinar informative, and feel free to email us, as I said, with any questions you may have. I'll mention again that the recording with a brief summary will be on drought.gov later this week and on the NATI's YouTube channel as well. Our next webinar is scheduled for Monday, January 27th, and you can register for that on drought.gov already. And up there is a QR code if you want to get onto any of our email lists if you aren't already, so these things just come to your inbox versus having to go find them. With that, I'll go ahead and close the webinar and say thanks everyone for joining us today, and I hope you have a great week.
Amanda, thank you. Real quickly in the chat, I put up where to sign up for the AR scale alerts and the Outlook alerts, but that only went to you. Do you mind sending it out to everybody if they're interested before everybody signs off?
I can do that real quick to everyone. And then we can also include these kind of things in the post email.
Great.
There you go. Thanks everyone. Have a good week.